Thank you. And just to say that Lucia Jeschonneck joined me today, and she also deserves applaud. Thank you. So, creative techies. Yeah, I think I came to amplify a signal, an emergency signal, which is coming from an ongoing battle which started already a long time ago, but which is now getting closer to us. And I'm going to present you a totally different domain than the one which have been discussed until now, where I think confidential computing could be an IT enabler which could support a lot of things, okay? So I have to click somewhere here. That's done. Even before we go to the battlefield, I say the battle has started. And a battle is not necessarily on a battlefield. The battle has started on what I will call the cloud part, where the social network and the artificial intelligence are already widespread and used. And it has started with influencing a lot of things in our democracy. And I would say, globally, we resisted good, but we lost the first battle, but we didn't lose the war at all. We lost the first battle, like, several countries very close to us were very quick and unexpected. Some people get almost elected. We lost the battle where some democracy suddenly turned into something we don't really understand what's going on, okay? We also lost the battle because the battle line, which is far away from us, we don't see that they deserve more attention from us, yeah? And in all of these aspects, the creative techies, you have a role to play, and I came today to ask you also to focus on that you need. Thank you. Now we go to the battlefield. And we go to a depth of a battlefield. So not everything is on the front line. A battlefield is composed into a depth, and this depth for the combat cloud, we tell it going through the core, which is mainly our nations, our, let's say, no-flight zone and safe area, and it is going progressively to the fog, which is more or less an advanced place where we are still secured, but already with the risk of confronting an enemy. And then we come to the edge, which is really the in-contact zone with the enemy. Our defense is organized into different domains. So you know the land, the marine, and the air power, okay? What is coming recently and is very well organized and is progressing quickly is the cyber defense, yeah? Due to the cyber attack. All of these domains, they try to create what we called a multi-domain combat cloud, okay? Where all of these forces which you see on this battlefield can, within seconds, communicate together, exchange information safely, align decisions, and act. We call this chain the command and control, intelligence, surveillance, and reconnaissance chain. If you add to that the computing and the communications which we represent, you have this C4 ISR concept, which I try to represent on one schema. So it was just to introduce a little bit what we talk about. And on that, what your technology can bring. 3 elements: sovereignty, immunity, and resilience. Okay? And these 3 elements, these 3 capacities, will probably help to make the difference on the long run. It's good to be sovereign, but if you are not immune, then your system is destabilized by influencers, okay? It's good to be sovereign, but if you are not resilient on the long run, then slowly you spread all of your munitions in at once, and you don't save it for the future. All of these aspects could be helped by multi-domain operations, artificial intelligence, and the combat cloud you could build with us. Sorry, wrong way. Now, how do we help usually these forces? At each node, what I will call a node is, for example, a truck here on the right, a submarine, a plane. At each node, we try to bring in what we call the mission computer with 2 functions: computing locally, communicating with the others, okay? On that node, we have a usual, always the same abstract of an architecture. And this abstract, I will present it on the next slide. So here, I wanted to highlight the different nodes, the different domain on the first line, air, land, sea, space, cyber, okay? And what we try to do in the depths of the node, we try to make all of these elements communicate and process the data to the best effectiveness for the things we're trying to do. And here today, we focus on this distributed IT infrastructure, how we build it, and how we serve it. And there are three elements where Airbus is looking at: the secure cloud and IT infrastructure service, that's one. The secret up to secret and confidential on-premises cloud systems, what we bring in the different vehicles, let's say, okay? And also the deployable cloud-based information system, which can be even on the edge part, being a terminal for a soldier or something interacting directly on the combat field. Now that we are focused on that, how does one of these nodes look like? Yeah, it depends. That's the problem. Each platform has a different size. Each platform has a different power supply. Some are flying, some are not mobile, some are fixed, and so on and so forth. So we always need to build this mission computer and its network capability, but based on where we have, we don't have the same needs of processing and networking. And we try to find the best balance between what we bring in and what we need to do with it. We try also to deploy the massive artificial intelligence as an enabler of all this capability. But we don't do the same in the cloud. That's what we do in the edge. So we have to see how we distribute the AI capacity over the IT infrastructure and its depth. So I took some example here just so that you have the different configuration or the different stacking we find at each level. And what we try to push as a trend on the moment is also to say the infrastructure should be dematerialized, and that's where confidential computing also helps. We need to have a software-defined infrastructure to support a software-defined defense. And this is what we are working on. The pattern we use here shows at each level more or less the kind of hardware we are facing, where the processors are changing very quickly. In the past, it was just CPUs, then came CPUs, GPUs, now came CPU, GPU, FPGA, and so on. Yeah? There is also another challenge which we have, is that on the edge part, we are sometimes in a very mini drone, so we need to miniaturize drastically what we had. So the same functions should be more or less on a microcard or on a chip or something like that. All of these aspects are challenged. But what we wanted to address with confidential computing as a first proof of concept, and this is the one we are going to demonstrate today, is this initiative. So first, I met Edgeless in a cloud acceleration initiative within Airbus. We met last year with Thomas. And we looked immediately at the interest, the solution which was presented as, the Green Sea. The Green Sea would help on all these cloud aspects which we have mentioned before. Like on the public sector initiative, we could port it to the defense sector without any problem. But more interesting is what we could do with this contrast, which was explained just before, and how we could use it for the fog part. And what is the fog part? A sample of a fog part would be, this vehicle, for example. What I would like to be able to do on that vehicle is three things. It should serve the communications on a radio cell, which is allowing communications between all the infantry which are around, for example. It could pilot some of the surveillance drone, or at least collect the video which are required from them and process them further. It could extract out of these video signals the metadata, which would be very interesting for example, an artillery, yeah, to reach the target. So we need to bring inside a mission computer, an hybrid communication, and we also need, if possible, to have this easy to interface management layer for deployment of the applications which come on top. And that's where we said a secured container is probably a very good approach. Yeah? And that's also where we say putting the LLM models or whatever we need to bring on top is also a good to have a containerization as a service as an enabler. Then we said, okay, but if we bring it into the truck and it's taken by the enemy, how do we face the problem? There are plenty of solutions. It's not a new problem in the army. But at least we say, hey, here also the confidential computing could bring something. Could bring us the certitude that the machine we are talking to is really one of us, a blue force, for example. It could also help the cyber resilience in the sense, in the past, we just protected from the EMC part, okay? But there are new elements in the EMC aspect which we would like also to contest. And this is mainly these three elements which we have been looking at. The physical loss, yes. What do we do if we lose the device? And how do we deactivate its mission computer, for example, or don't let the enemy to use it? The compromised infrastructure, then we don't have anymore, for example, the remote attestation, so it means it's inactive by this lack of remote attestation. And if we have an insider threat, how could we avoid that somebody is taking the data which were on that computer, which could have a usefulness for them? Okay? And I think this is where I pass it to Lucia.
Thank you, Luke. Let's us go to the next page. I'd like to show you a proof of concept how we have migrated one of our how we have moved a command and control service we have now in the classic Kubernetes to move it to confidential computing. It's very classical. We have a web application with a front end, back end, a data bank, and key cloak for login and management. I have discovered in the proof of concept that we need to adapt our deployment. For example, we have Kata, which create VMs, for which we cannot use a subpass because it's not supported. Or we need to adapt the connection between the containers and use from Qantas the mesh network to secure all connection between them. The other point is also that in Kubernetes, the ingress controller, what is used, is today not supported or not secured by Qantas. So we need to deploy our own one, secure them, and secure the connection between all of them to have the end-to-end path decryption and secured the complete way. And to the end, what is also very interesting, we create VMs. And this need more space as before. So we need to adapt the limit what the container need, for example, for VMs. So then let's go to the last one. This is a shortly architecture view, how it's look like. We have each of the servers, which are in a Kubernetes cluster, and we connect it. And I like shortly that we start the demo. Can you start the video, please? Okay, here you can see a Ranger cluster in which we can see the demo running. You can see some information for them. I like now to go to the deployment, for example, to the database. And you can see then that we have multiple init container for the initialization with create VM, the mesh network, and also the data bank in its own. And now we like to go to the running scenario. This is a command and control view which show all assets or information we have generated on a map. And you can see here what is happening there. Okay.
Yeah, so the function you saw, the common operational picture which you saw before is the one, for example, we need to deploy on all vehicles and all stuff like that. So we just wanted to take a proof of concept which is showing that we can already operate our command and control activities on, let's say, a secured container using confidential computing. So this was really the target of this very first initiative. It was to vulgarize it a little bit for our customer and explain that it's already possible with what is on the table in the portfolio of very few companies here in Germany, sorry, and why not to do it? Yeah, that's the question. Then the next steps, they are to verify that what we've done is indeed resilient and immune. And that will be probably the next steps which we will go on before we show our result and our conclusion to the AFCR in May in Bonn, which is more, let's say, a defense tech exhibition. And what we will do meanwhile, we will try to break it. We will try to check with our cybersecurity colleagues, are there still problems which need to be tackled? There is one of us, my colleague here, Michel, which is going also to secure on top. So we have heard we still need to secure the OS. When they are installed on top, we still need to be careful with how we secure the Kubernetes on top. And this is the kind of aspects which we put on the roadmap of the, let's say, next 3 and then next 6 months. Another things we look at is, I explained a little bit the strategic role of this C2 vehicle. And we have, in a digital twin, part of a bigger use case which we want to study for the Bundeswehr, which is what we call the joint artillery use case. I have explained this notion of resilience. Yeah. If I have an enemy and it deserves a bazooka to be killed, and I kill him with a missile, I am wasting resources. What would be cool is that once the attacker is identified and the target is defined, an artificial intelligence could really quickly decide, because a human being is under stress and cannot do it, which is the best casualty we can have at the lowest cost effectiveness. And this is what we would like to build as an image. And this is the roadmap for, let's say, more or less the end of this year. Yeah? Then I have explained, then you need not to have it only on one vehicle. You need to have it on a large number of platforms and to see how the interface is still functioning, how the shared information system is still functioning. And this would be the next approach, which we call the multi-domain operation use case. And also, we are still studying what we call the sovereign cloud service platform, cloud service provider platforms with people like, I think they were named a bit earlier. Stack IT was one and the others. So I just would like to say thank you to all the teams that participate to that, and thank you also to Edgeless again for the invitation today.
Thank you.